Alright, this is video 3 of the Stoichiometry video series, and we are going to talk about something a little bit new today. So this video is going to cover something called limiting reactants. We are going to learn what those are, and you're going to learn the steps to finding which reactant in an equation is going to be limiting. But before we get into any of that, if you could please pause the video and complete section G, which is the day 3 warm-up, and then hit play when you are finished. So these are the answers you should have gotten for section G. If you did not get any of these answers, please try it again, and if you're still not getting the right answer, please check with a classmate as to what you might be doing wrong. Now we're going to start talking about limiting reactants, and before I get into the actual chemistry of it, we are going to just simply use non-chemical terms. So we see a table, right, on the screen. We see a single table. A single table is made up of 4 legs and 1 tabletop. So if we were to put that into an equation, if we put 4 legs and 1 top as reactants, we would get out a single table. But now let's say that I only have 6 table legs, but I have an abundance of tabletops. I have as many tabletops as I want. How many tables could I build, and how did you come up with that answer? So you should have said that I could only build a single table, because I would simply run out of table legs. I would use 4 of them and 1 tabletop to make a single table, but then I only have 2 more legs, and you can't build a whole table with that. So because of the amount of table legs, it would limit how many tables I could make. But now let's say that I have 2 tabletops only and only 9 table legs. How many tables could I make, and how did you come up with that? So you should have said that I can only make 2 tables. I would use 4 of the table legs with 1 tabletop to make 1 table. I would use 4 more legs and a tabletop to make 2 tables, and I would have 1 table leg left over. So really, I am limited by the amount of tabletops in this case to how many tables I can actually make. So this is very similar to how reactions run. In a chemical reaction, one reactant usually is going to run out before the other one does. So the reactant that runs out first is called the limiting reactant, which you might see abbreviated as LR, and you are free to use that abbreviation. The reactant that is going to have some left over, like in the last slide we have leftover table legs, that is called your excess reactant, and you might see that abbreviated as XS for obvious reasons. Now the limiting reactant is the reactant that is going to determine how much product is going to be made. Just like how we looked at which part of the table was going to run out first to determine how many total tables we could make, that is the same for chemical reactions. So we are going to have to now find the limiting reactant, whichever reactant runs out first, and then use that to determine how much product is going to be made. All right, we are going to start with example problem number 5 in your packet, and we are going to practice finding the limiting reactant, there we go, and then using that limiting reactant to determine how much product is being made. So problem number 5 says, if 12 grams of aluminum reacts with 12 grams of oxygen gas, what is the limiting reactant and how much product is being made? So the first step is always going to be the same. You always need to make sure that you write out the chemical equation and that you balance it correctly. So please pause the video here, try step 1 on your own, and then hit play when you are ready. So you should have gotten the equation on this slide and balanced in this way 4 aluminum plus 3 oxygen, remember that oxygen is diatomic, that might have messed you up, goes to form 2 moles of aluminum oxide. The next step is to set up dimensional analysis, and we are going to put the mass of one of the reactants, and it does not matter which one you use. So you might have noticed that that was one of the big differences in this question as to the ones that you have been doing, is now I'm giving you 2 numbers in the problem instead of 1. So we are going to choose one of those numbers. It really doesn't matter which one. I always pick the first one. So if you want to pick the first one as well so that we can do the problems together and do them a little bit the same, then go for it. But it really doesn't matter which one you use. Whichever one you use, you are going to put it in the upper left-hand box of dimensional analysis. And remember that you need to put units and labels on it, or this is going to get extremely confusing. So I'm starting with the 12 grams of aluminum just because I've always started with the first one. Again, you could start with 12 grams of oxygen gas. But for this problem, let's all just use 12 grams of aluminum. We are putting it in the upper left-hand box of our dimensional analysis. Now the next step is to go through reaction stoich and convert the amount of grams of aluminum into grams of the other reactant. So we're no longer going to the product right away. We have to go from reactant to reactant. So we're going to go from aluminum to oxygen gas. And your answer that you get out, which I'll show you in the next slide, is how much of the other reactant you need to react your starting substance completely. That's a big key point of this. So when I go through reaction stoich, I started with 12 grams of aluminum. I put grams down. I need to convert that into moles using a simple mole conversion. And I know that there are 27 grams of aluminum in 1 mole. Then I know that I need to use a mole-to-mole ratio using the balanced equation in order to convert from aluminum into my other reactant, which is oxygen gas. So I see in my balanced equation that for every 4 moles of aluminum, I have 3 moles of oxygen. And then I need to convert that, my moles of oxygen into grams of oxygen using a simple mole conversion. So that is why I put the 1 mole of oxygen down and 32 grams up. And then you can go through and solve it. So I just went through and I plugged in 12 times 1 times 3 times 32 divided by 27 divided by 4 divided by 1 to get that I would need 10.67 grams of oxygen in order to react all of my aluminum. If you did not get this answer, please try plugging it into your calculator again, because a lot of times we don't plug it in to our calculator correctly, and that gets us a little bit in trouble. The next step is to use that number that we just calculated and look back into the problem to actually determine the limiting reactant. Now, if your answer is more than the amount of the substance you started with from the problem, then your ending substance is the limiting reactant. If your answer is less than the amount of that substance you started with from the problem, then your starting substance is your limiting reactant. So let me show you how I usually do it with my problems. It sometimes helps. And then I'll give you a little metaphor that I used to use in high school and college that really helped me learn this, because this can be a little confusing. So I always go through my reaction stoich, find how much reactant I need, and then I write it out in this way. I need 10.67 grams of oxygen to react all of the aluminum. From the problem, it says that I have 12 grams of oxygen. And I always thought of this like money. So let's say that I want to purchase, well, I've been using tacos in my metaphors. I want to purchase a giant taco for, it says it's $10.67. I am carrying with me $12. Do I have enough to buy that taco? Obviously I do, and I'm going to have extra at the end of extra money that I can spend on something else. So that means that my O2 is my excess reactant. I will have some left over. And so that makes the aluminum my limiting reactant. So I had more oxygen than I calculated, which means my other substance is going to be my limiting reactant. So that's what this is going to state. So now that I have found the limiting reactant, I'm going to now use the amount of the limiting reactant that I have in my problem, the amount that I started with in the problem, and I'm going to use that to calculate how much product is being made through a simple reaction stoich problem. So if you could please pause the video, I want you to start with the amount of the limiting reactant, so that is the aluminum. So the amount of aluminum given to you in the problem is what you're going to start with, and you are going to go through reaction stoich to find out how much product or aluminum oxide is going to be made. So please pause the video, try that, and then hit play and we'll see if you did it correctly. So this is what you should have gotten. You should have found that 22.67 grams of aluminum oxide was going to be produced. We started with the 12 grams of aluminum in the problem. We did a simple mole conversion to turn that into moles of aluminum. We then used the balance equation to get a mole-to-mole ratio to convert from aluminum to aluminum oxide. And then we used another simple mole conversion to convert from moles of aluminum oxide into grams. And you should have gotten an answer of around 22.67 grams of aluminum oxide being produced. Now it's really important that you understand why we need to use the limiting reactant when calculating how much product is being made, because the reaction is only going to run as long as there's reactants, both reactants left. If the aluminum runs out, then the reaction stops. So if we were to use oxygen as our starting point here, this is not going to run to completion. This is based on the idea that whatever we're starting with is going to be used up completely, which isn't the case for oxygen. We're going to have oxygen left. So you have to use the reactant that is going to run out completely, or else you are going to get an answer that is incorrect. You're going to have a higher answer than you should. We're now going to move on to example problem number 6 from your packet, and I'm going to kind of run this the same way that I did in the past, where I'm going to explain the step. I'm going to have you pause the video, try that step on your own, and then come back and see if you got the step correct. So problem number 6 says if 45 grams of chlorine gas reacts with 30 grams of sodium, what is the limiting reactant and how much product is being made? So the first step again is to write out the chemical equation and balance it. So try pausing the video, writing the chemical equation, balancing it, and then hit play when you are finished. So you should have gotten the equation below. We have chlorine gas, which is Cl2 because it is diatomic, reacting with 2 moles of sodium, going to form 2 moles of sodium chloride. The next step is to set up dimensional analysis. You can pick which reactant you want to start with. For simplicity's sake, I'm starting with the first one if you want to follow along with the work that I have for you. You are going to put the mass of that, whichever reactant you want to start with, in the upper left-hand box, remembering to use units and labels. So why don't you take a second, do the first reactant just so that we can be on the same page. Put that in the upper left-hand box. So you should have placed the 45 grams of chlorine gas in the upper left-hand box for this step. Again, in the future, when you do problems on your own, you can start with the other reactant, it doesn't matter. But just because I started with the first one and I'm showing you my work on these slides, we're going to do it the same way. The next step is going to be to use reaction stoich to convert from grams of chlorine gas into grams of our other reactant, which in this case is sodium. Your answer, remember, is how much sodium you need in order to react all of your starting substance. So whatever answer you get out is how much sodium you need to react all of the chlorine gas completely. So why don't you pause the video, go through the reaction stoich, find out how much sodium you need to react all of the chlorine gas. Hit play when you're finished. So going through the math, you should have found that it is going to take 29.15 grams of sodium to react all of the oxygen. I'm sorry, that should say Cl2, whatever. If you are not understanding the reaction stoich process at this point, please go back to videos 1 and 2 and please review that because I'm going to start running these videos as if we understand the reaction stoich process just to save you a little bit of time. So you should have found that it takes 29.15 grams of sodium to react all of the Cl2. I'm sorry, it says O2, it should be Cl. The next step is going to be to determine the limiting reactant. So this is where you compare your answer that you just calculated to the number in the problem. Again, I like to write out how much I need. So that's your answer, the 29.15 grams of sodium, and then how much I have, and then compare it. And again, I like to use this in terms of money because it makes more sense, but you can kind of figure it out however it works for you. So take the time to do that and hit play when you're finished. Now remember that if your answer is more than the amount you started with, then your ending substance is your limiting reactant. And if your answer is less than the amount that you started with, then your starting substance is your limiting reactant. So in this case, we got out 29.15 grams of sodium. So we need 29 grams of sodium. We have, from the problem, 30 grams. So our answer is less than what we have, making the chlorine gas the limiting reactant. Okay, you can think of it again like buying something. I need $29.15 to buy something. I have $30. Therefore, I can purchase that item and still have excess money in my wallet. So therefore, the Cl2 is going to be our limiting reactant. And then the next step is going to be to use the amount of the limiting reactant from the problem to calculate how much product is being made going through simple reaction stoich. So please pause the video, try this step on your own, and then hit play when you are finished. So through reaction stoich, starting with the 45 grams of chlorine gas, you should have found that you would get out 74.15 grams of sodium chloride. If you did not get this answer, please retry it in your calculator, check your work, and if you still are not getting the correct answer, please check with someone around you. This is the end of video 3.